This lesson video is for section 4.4 factoring quadratic expressions. Our objectives for this lesson are that we can find common and binomial factors of quadratic expressions, as well as we can factor special quadratic expressions. So let's begin by talking about what factoring is. It is the process of rewriting an expression as a product of its factors. We can factor many quadratic trinomials in the form ax squared plus bx plus c into the product of two binomials. Before we actually factor an expression, let's review FOIL or table method that we learned in Algebra 1. These methods assisted us in the process of multiplying two binomials. So I'm going to show you FOIL method. F stands for first, so when you multiply the first two terms you get x squared. O stands for outer, so x times 2 is 2x. I stands for inner, so 4 times x is 4x, and L stands for last, so 4 times 2, which is 8. You combine the like terms in the middle, and you add them, so you get 6x in the middle. The first term and the last term drop down. So this would be the trinomial that's produced by the multiplication of these two binomials. I'm going to show you the table method that my Algebra 1 kids typically prefer over FOIL, because it's a little bit more visual, and it reminds people of lattice multiplication. It's very similar, just a different format. So same thing, we're multiplying, so x times x is x squared, x times 2 is 2x, 4 times x is 4x, and 4 times 2 is 8. The like terms are on the diagonal here, so when you add those you get 6x, and then you just take the first box, the top left box, the middle combined term, and the bottom right box. So you get the exact same quadratic trinomial as in the FOIL method. So these two methods help us multiply binomials. The process of factoring is the reverse of this distributive property FOIL or table. So now I will show you the process of factoring. So now I'm going to factor this trinomial that we ended up with, x squared plus 6x plus 8. And the method that my Algebra 1 kids prefer is called the x method. It's just a way to organize the numbers that we're working with. So you want to take the last number, which is 8, put it on top of the x, and the middle number, which is 6, put it on the bottom. What you want to do is figure out two numbers that multiply to give you 8, but at the same time, when you add those two numbers, you get 6. And fortunately, everything's positive, so this is the easiest case. And hopefully you're thinking 2 times 4 or 4 times 2. It works. When you multiply, you get 8. When you add them, you get 6. So then what you want to do is take both of those numbers and put them in the parentheses. So you have x plus 2 times x plus 4. And you can see that if you reverse the order, when you remember when you're multiplying, the order doesn't matter. If you reverse this order, you get the exact same expression, those two binomials that we started with when we FOILed and when we used the table method. So now I just showed you one basic example of how to factor a quadratic trinomial. So here in example 1, we have another opportunity to practice factoring, and the a value, the leading coefficient, is either going to be positive 1 or negative 1. When the leading coefficient is another number besides 1, that'll be a different situation. We'll see that later in this lesson. So when we factor, we can use a table of different possible factors of the constant term. That may be helpful in organizing the numbers that we have to work with. So I'm going to be using the x method for all three of these to keep a consistent method going. So hopefully you can follow. So let's take a look at the first quadratic. We have x squared plus 9x plus 20. So when you make the x, the 20 goes on top and the 9 goes on bottom. You want to think of two numbers that you multiply to give you 20 and add to give you 9. So what I typically do is I make a little table on the side, and we can write factors of 20. And then when you add those, so sum of those factors. So the factors of 20 are 1 and 20, 2 and 10, and 4 and 5. Now let's add those. For the first pair, we get 21 for the sum, 12, and 9 respectively. So now you can see that the last pair of factors, 4 and 5, would work for this situation. Because when you multiply, you get 20, and when you add, you get 9. So that means our factored form is going to be x plus 4 times x plus 5. In part B, we have the quadratic x squared plus 14x minus 72. So setting up my x, I have negative 72 on top and 14 on bottom. So we want to think of two numbers that multiply to give you negative 72 but add to give you 14. So let's take a moment and make a similar table. And the factors would be -1, 72, -2, 36, -3, 24, -4, 18, -6, 12, and -8, 9. And you can notice that in each of those pairs, I have the smaller number being the negative. Because we're multiplying to get a negative, that means one of the factors has to be positive, one has to be negative. But when we add those numbers, we're getting a positive number. So that means out of the two numbers that we're multiplying, the smaller one needs to be the negative. So now let's add each of these to see what our sums are. 71, 34, 21, 14, 6, and 1. So you can see that the factors -4 and +18 are satisfying our x method. So we want to take -4 and 18, and we want to write that in factored form. So x minus 4 times x plus 18. In part C, we have a quadratic with a leading coefficient of -1. Before we do the x method, what we need to do is factor out that -1, because we cannot use the x method unless we have a leading coefficient of +1. So when we're factoring out -1, we're essentially just changing the signs of each term of the quadratic trinomial. So we have, inside the parentheses, we have x squared minus 13x plus 12. Factoring out -1 will not change the answer because the final factored expression will include -1 as a factor. So now we can take care of the quadratic trinomial that's inside of the parentheses, and we'll be using the x method again. So 12 on top and -13 on bottom. You can continue to make a table if that helps you, or if you can do it in mental math, that would be fine. So the factors that would work for this would be -1 and -12. And the reason why these work is because when you multiply two negatives, such as -1 and -12, you get +12. But when you add these two negatives, you get a number that is a slightly more negative, -13 in this case. So now let's take those numbers and write them in factored form. So we still have the -1 out front, and now we have in parentheses x minus 1 times x minus 12, and that would be the factored form. Hopefully remember the term greatest common factor, or GCF abbreviated. The greatest common factor is a common factor of the terms in an expression with the greatest coefficient and the greatest exponent. We can factor any expression that has a GCF not equal to 1. So here in example 2, we have two different expressions, and we need to figure out the GCF of each and factor them out. So taking a look at 6n squared plus 9n, we need to figure out the GCF of this expression. The greatest number in common between these two terms is 3, and for the variable, you can take out an n in each. So you want to take out the GCF, which is 3n, and then we're going to be factoring that out, putting it in front. So what do we need to multiply 3n by to get 6n squared? Well, that would be 2n. And what do you have to multiply 3n by to get 9n? That would be 3. So you can see that we have a factor of 3n. So now what we want to do is take the GCF, which is 3n, and put it in front. And now we just have what's remaining in the parentheses. So if you were to distribute this, you would get the original expression that we started with. So 3n times the quantity 2n plus 3 would be the factored form. Now some people have a harder time figuring out GCF visually. So this is how I introduce it to my Algebra 1 kids. I write out the factors separately, and then I write down the prime factors out like this. And then what you do is you circle the like terms, what they have in common. So you can see that the terms in common will be 3n, so that would be the GCF, so that goes in front. And then whatever's in the parentheses is whatever is not circled. So you can see right here we have 2 and n. That would be 2n for the first term, and then 3 is the last term. So that is another way to do the GCF process. Taking a look at part B, we have the expression 4x squared plus 20x minus 56. Well, there isn't a variable in common because the last term, the c value, does not have a variable. So that means the only thing in common must be a numerical factor. So taking a look at the numbers 4, 20, and 56, I think to myself, maybe 4 goes into it. I know 2 goes in because they're all evens, but I actually think that 4 would be the biggest number in common. So now what we want to do is factor out the 4, put it in front, and multiply what we need to multiply to get the original expression. So 4 times x squared, and then 4 times 5x, and then 4 times -14. So if you were to multiply those terms, you get the original. So now what I want to do is take out the 4, which is the GCF, put it in front, and then whatever's in the parentheses just drops down. X squared plus 5x minus 14. And then from there, we can actually factor what's inside the parentheses. You can see that there's an invisible leading coefficient of 1, so we can actually use the x method that we were just practicing. So negative 14 and 5 go here. I know that I need to multiply to get a negative, so that means my factors must have a positive and negative. And the bigger number out of the two needs to be positive because when I add them, the sum needs to be positive. So 7 and negative 2 would work. So drop down the GCF. The GCF just stays in front the whole time. And then now let's take our numbers that we just found in the x method, x plus 7 times x minus 2. And that would be the factored form of the original quadratic. Now we're about to talk about the process of how to factor a quadratic trinomial of the form ax squared plus bx plus c when a does not equal 1. And there's no common factor that we could factor out. What we're going to do is rewrite the middle term, which is the bx part, as two terms. The coefficients of these two terms will be the factors of AC that have a sum of b. So let me show you how to do this. In part A, we have 2x squared plus 11x plus 12. So the first thing that I want to do is identify my ABC values. And then I'm going to multiply the a and the c, which is 2 times 12, and that is equal to 24. So now I'm going to do the same x method, 24 and 11. And you can see everything's positive, so the numbers that will work will be 3 and 8. They multiply to give you 24 and they add to give you 11. So now let's rewrite this with the middle term being two terms. So the first term stays the same, 2x squared. Now we're going to be taking the pieces of the x method, so the 3 and the x, and we're going to write 3x plus 8x. So we're just splitting up the 11x into two numbers that add to give you that number. And then the last term, 12, drops. Now the order of these middle two terms does not matter, and that's good news because you can choose either order and you should get the exact same final answer. So you could do 8x plus 3x if you wanted to. So now what we're going to do is called factoring by grouping, and this was touched upon in Algebra 1. So what you want to do is focus on the first two terms and the last two terms and keep the plus sign in the middle. So we're going to be doing the GCF process twice. So take a look at the first two terms. The GCF for the first two terms would just be x. So you want to factor out an x, and then when you factor out an x, you still have 2x plus 3 inside. And if you are struggling with the GCF process, you can always distribute the number in front to check to make sure you did the right thing. So now let's take a look at the last two terms, 8x and 12. The GCF of those two terms is 4, so I'm going to take out the 4, put it in front. And what I need to multiply by 4 to get the original is 2x plus 3. And hopefully you're noticing that the term or the expression inside the parentheses are the same. So that means we did the right thing. So what we want to do now is take the GCF, essentially the 2x plus 3, and hopefully you're seeing that it's the same thing in both terms. We can factor that out, and then when we factor that out, we just have x plus 4 left, aka the coefficients, the numbers in front. So x plus 4 drops, and that would be the factoring process. So we have 2x plus 3 times x plus 4. And you could always use the FOIL or the table method to check your answer to make sure you got the original. Now let's take a look at part B. Okay, in part B, we have 4x squared minus 4x minus 3. So I'm going to be using the exact same process as I did in part A. So I'm going to factor or multiply the a and the c values. So we have 4 times negative 3, which is negative 12. So that's going to be the number on top of my x. So negative 12 and negative 4, which is the middle term or the b value. So you can see that we're multiplying to get a negative. So that means one number has to be positive, one has to be negative. And when we add, we get a negative. So that means out of the two numbers, the bigger number has to be the negative. So hopefully you're thinking to yourself that negative 6 and positive 2 work for this situation. So now I want to write the expression, keeping the first term as 4x squared. The middle two terms are going to be negative 6x and positive 2x, and then I'm dropping down the c value, which is negative 3. So grouping the first two terms and the last two terms, we're going to be using the same GCF process. So the GCF of the first expression is 2x. So when you factor out 2x, you should get 2x minus 3 in the parentheses. For the second expression, we actually just have a GCF of 1, so I'm just going to factor out a 1, and we still have the same expression, 2x minus 3. And that's because there were no other common terms besides 1. So you can see that our common expression is 2x minus 3, so I'm going to factor that out and put it in front, 2x minus 3. And then what comes down is the leading coefficients of each of those, so 2x plus 1. So essentially we're going like this, just to draw some arrows to show you what's happening. So our factored form would be 2x minus 3 times 2x plus 1. Now let's talk about a couple special cases of factoring. The first one's called a perfect square trinomial, and that is a trinomial that is the square of a binomial. So let's take a look at this very basic example, x squared plus 10x plus 25. If you were to do the x method with that, you would have 25 on top, 10 on bottom. The two numbers that work are 5 and 5 again. So you can see that we're getting the same number for both sides of the x. So in factored form, that would be x plus 5 times itself, and hopefully remember that you can condense that into just x plus 5 squared, because that little 2 up in the exponent just means you're multiplying that expression by itself. So this is what's called a perfect square trinomial. It works whenever the first term and the last term are both perfect squares. And this key concept box right here will help you determine when we can use the perfect square trinomial shortcut. So now let's take a look at one example below. We have the expression 4x squared minus 24x plus 36. And this is another perfect square trinomial. So if we were to write 4x squared as the quantity squared, we would write 2x squared. And if we were to write the last term, 36, as a quantity squared, we would write 6x, or 6 squared. Now the middle term is the product of negative 2 times the first term in parentheses and the last term. And when you multiply negative 2, 2x, and 6, you get negative 24x, which is the middle term. So this confirms that this is a perfect square trinomial. So what's nice about this is that you can just take the first term and the last term squared, drop them down, 2x and 6. The middle sign is the sign of the middle term. So because we had a negative 24x in the middle, you drop down the negative sign, and you just square the entire expression. So 2x minus 6 squared would give you the original expression. Let's check to make sure that that works. We can use the table method or FOIL. So when you multiply those factors, we get 4x squared, negative 12x, and 36. When you multiply, or actually when you add these like terms, you get negative 24x. And then the first term is 4x squared, the middle term is negative 24x, and the last term is 36. And hopefully you realize that when you have a quantity squared, you just write the same label on both sides of the table. And this confirms that we did indeed factor this correctly. So a perfect square trinomial is one of the two special cases that we will come across. Now let's take a look at the other case, and that's called factoring a difference of two squares. So this process works when you have a quadratic that is only a binomial. You can see the middle term is canceled out. And then we have perfect squares in the front and the back. So we can write this as x squared minus 3 squared, similar to what we did in the previous step. We just don't have to worry about the middle term. And then from there, in order to cancel out the middle term, you have to have a positive and a negative in your two sets of parentheses in order to cancel out that middle term. And then the first term of each is the x, and the last term of each is the 3. So if you were to multiply that expression, you would get x squared minus 3x plus 3x minus 9. You can see the middle two terms cancel, so we get the original expression of x squared minus 9. So now let's take a look at example 5, which is a slightly more complicated version of the example we just did. So 25x squared minus 49. We need to put this in factored form. I know that this is the difference of two perfect squares because I can see that the first term, 25x squared, can be written as 5x squared, and the last term, 49, can be written as 7 squared. So now I am going to just take the first term of each, which is 5x, and put it in the first spot of each set of parentheses. Make sure you have a plus and a minus so that the middle terms do cancel out, and then the last term is just 7. So this in factored form would be 5x plus 7 times 5x minus 7. And you, of course, could do the FOIL method or the table method to check your answer. Okay, that completes this lesson. Here's the lesson check problems for today's video. You can do all of them if you'd like the extra practice, but the ones that I'm going to require you to do are the evens. So do 2 through 10 even. I'm hoping that a lot of the factoring processes from Algebra 1 came back to you in today's lesson video. Don't worry if you are not 100% positive on them yet. We will continue to practice and review this tomorrow.